This would be a level 2 question. The sequence P1, P2, P3 is defined by P1 is 211, P2 is 375, P3 420, P4 523, and Pn is equal to Pn minus 1 minus Pn minus 2 plus Pn minus 3 minus Pn minus 4 for all n greater than equal to 5. And we have to find the value of P531 plus P753 plus P975. Now, let us first find the value of P5 by substituting n equals 5 in the expression. So that is equal to P4 minus P3 plus P2 minus P1. Now, P4 has been given as 523 minus P3, which is 420, that's 103, plus P2, which is 375, so that's 478, and minus P1, so that's 211. That's 278, that's 268, so 267. Hence P5 is 267. Now let's look at P6 by substituting n equals 6. P6 is nothing but P5 minus P4 plus P3 minus P2. P5 now can be written as P4 minus P3 plus P2 minus P1. So now then we subtract P4 plus P3 minus P2. Let's see what we are left with. P4 minus P4 minus P3 plus P3 plus P2 minus P2. Hence P6 is nothing but minus P1. P7 would be equal to P6 minus P5 plus P4 minus P3. P6 would be minus P1. P5 has been given to us, so subtracting negative of that, so it's minus P4 plus P3 minus P2 plus P1. Then we add P4 and minus P3. So it's minus P1 plus P1 minus P4 plus P4 plus P3 minus P3. So we're left with minus P2. Then look at P8. So that will be P7 minus P6 plus P5 minus P4. Again substituting all that we have. So P7 becomes minus P2. P6 becomes minus P1. So minus of P6 will become plus P1. Then I have plus P5. So that will be plus P4 minus P3 plus P2 minus P1 minus P4 eventually. So that's minus P2 and plus P2 get cancelled out. So I have plus P1 and minus P1 get cancelled out. Plus P4 minus P4 get cancelled out, left with minus P3. Continue to P9, that will be P8 minus P7 plus P6 minus P5. So we substitute again, minus P3, then plus P2, P6 is minus P1, P5 is minus P4 plus P3 minus P2 plus P1. So this is minus P3 and plus P3. This is plus P2 and minus P2, minus P1 and plus P1 with minus P4. Then P10 is P9 minus P8 plus P7 minus P6, which would be minus P4 plus P3 minus P2 plus P1, which is nothing but minus of P5, we can observe it. So what we see is P6 is minus P1, P7 minus P2, P8 minus P3, P9 minus P4, P10 minus P5. So what is happening is, from P1 to P5 I have certain values, P6 to P10 are negative of P1 to P5 respectively, that is P6 will be negative of P1, P7 negative of P2, so on and so forth. So for each set of 10 terms, that is what we are getting. Hence, when we have to find P of 531, what we see is P of 531 would be nothing but P of 1, because it is 530 plus 1, that means a multiple of 10 plus 1. Hence, P of 531 is nothing but P of 1. Similarly, P of 753 would be nothing but P of 3. and P of 975 would be nothing but P of 5. So adding P of 531 plus P of 753 plus P of 975 is P1 plus P3 plus P5. Now P1 is 211 plus P3, which is 420, and plus P5 is 267. So add this, that's 400, 600, 800, 860, 880, 890, so that's 898. Hence the answer is option A.